In this video, we're going to go over the Bronsted-Lowry theory of acids and bases. Bronsted theory-Lowry of acids and base is a broader theory of acids and bases than the Arrhenius acids and bases. The Bronsted-Lowry acid is an acid that is a substance that donates a proton, a hydrogen, to a base. The Arrhenius acid is a substance that produces hydronium ions in aqueous solution. A Bronsted-Lowry base is a substance that accepts a proton from an acid and has one or more non-bonding pairs of electrons. So Bronsted-Lowry acids, the hydrochloric acid donates a proton to a water molecule, which acts as a base by accepting the proton molecule. So the water grabs this hydrogen, makes this hydronium ion, and a chloride ion. The hydrochloric acid donates this hydrogen to the water takes it, and the hydrochloric acid donates it, and the water accepts it and makes this hydronium ion. This is also an Arrhenius base, or Arrhenius acid, but it satisfies the Bronsted-Lowry definition as well. A conjugate acid and base are the ion or molecule produced when an acid loses a proton, and it's called the conjugate base. A conjugate base of an acid has one fewer hydrogen atoms and a charge 1 unit more negative than that of the acid. Water acts as a base, accepting a proton to form the conjugate acid. So water accepts this proton and forms the conjugate acid. This acid has one more hydrogen and a charge 1 more unit positive than the base. So hydronium ion is H3O plus, water is H2O. Water has no charge. H3O has a plus charge, has a plus 1 more positive, and it has 1 more hydrogen. So the water is the base, and a base forms a conjugate acid. The acid loses a hydrogen, and the resulting molecule is called the conjugate base. Ammonia acts as a base by accepting a proton from a water molecule, which acts as an acid. So the ammonia grabs this hydrogen, and the hydrogen, so then the water therefore acts as an acid, donating this hydrogen back. And you get left with a hydroxide ion and a new nitrogen-hydrogen bond and a plus charge. The double-headed arrow right here in a chemical equation indicates that the reaction is reversible. So the reactants can go to the right, the forward reaction, and create the products, and then the products can go back to the reactants and create the reactants. The non-bonding pair of electrons on nitrogen and ammonia become the new nitrogen-hydrogen bonds in the ammonium ion. As you can see with those two reactions, that water can act as an acid or a base, according to the Bronsted-Lowry theory, because it can either accept or donate protons. Any substance that can act as an acid or a base is called an amphoteric compound. So in this first one, water grabbed the hydrogen from the acid and created a hydronium ion, so it acted as a base. In the second reaction, ammonia grabbed the hydrogen from the water, and the water donated this hydrogen, and the water acted as the acid. So in summary, according to the Bronsted-Lowry theory, an acid is a molecular ion that donates a proton to a base, and a base is a molecular ion that accepts a proton from the acid. When an acid is added to water, the acid donates a proton to water to form the conjugate base, and the water accepts the proton to form hydronium ion, the conjugate acid of water. When a base is added to water, the base accepts a proton from water to produce the conjugate acid, and water donates a proton to the base to form hydroxide ions. Amphoteric compounds can act as either an acid or a base.